In the last video, we answered the question, what is Node.js? In this video, we're going to turn our attention towards the why behind Node.js. So why is Node.js a tool you should spend your time learning? And why is Node.js a good tool for the job of building out applications? Now, as you know, based off of the fact that you're here taking this class, more and more when people want to learn a new backend technology, they are choosing Node.js as their tool of choice. The Node.js skill set is in hot demand, with companies like Netflix, Uber, and Walmart all using Node in production. Node's also useful for developers anywhere on the stack. So we have front-end developers who might need to use a little Node here and there to compile their apps or maybe serve up a website they're working with. And obviously, back-end engineers are using Node.js extensively to build out their web app backends, APIs, and command line applications. Now, in the last video, we broke down this first sentence. We talked about how Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine. In this one, we're going to break down the other two sentences. There's only 3 total. We got this second one and the third one. Now you'll notice that you don't have those second 2 sentences on your screen. If I were to load up nodejs.org, I just get that first sentence we already discussed. In the past, this was the complete summary on the website, and I've cached it so we can talk about it. In my opinion, I think it's a shame they took it down because it concisely summed up why Node.js is an ecosystem worth getting into. Let's go ahead and start with that second sentence. Node.js uses an event-driven, non-blocking I/O model that makes it lightweight and efficient. Now, let's just focus on non-blocking I/O. What exactly is I/O? I/O stands for input-output, and your Node application is going to use I/O anytime it's trying to communicate with the outside world. So if your Node app needs to communicate with the machine it's running on, that's I/O. For example, reading some data from a file on the file system. If your Node app needs to communicate with some other server, that's I/O as well. For example, querying a database to fetch some records for a given user. That's going to be an I/O operation, and I/O operations take time. Now with Node.js, we get non-blocking I/O. That means that while your Node application is waiting for a response, let's say a response from that database, it can do other things. It can continue to process other code and make other requests. Now, non-blocking is actually from the browser. So non-blocking I/O started in the browser because otherwise the browser would completely freeze up whenever an I/O operation was happening. So if I was trying to fetch some data to render it to a user, while that data was being fetched, the user wouldn't be able to do anything. They wouldn't be able to click links or buttons, and obviously that's a bad experience. With non-blocking I/O, it frees up the browser to allow the user to interact with the user interface while those I/O operations are running in the background. And the same thing is true with Node. We can continue to do other things while we're waiting for those long-running I/O operations to complete. And this is a critical feature of what makes Node so great. And I put together a quick visualization so we can compare non-blocking to blocking I/O. In this quick visualization, we're going to work through 2 code examples. Now, both code examples aim to get the exact same thing done, they just do it in slightly different ways. On the left-hand side, we have a blocking example. On the right-hand side, we have a non-blocking example. And there's no need to write any of this out, as we're just going to explore how these programs would execute using these timelines down below. That's going to allow us to visualize the differences between blocking and non-blocking I/O. Now, what do we have here? We have a bunch of regular JavaScript code. The only thing specific to Node.js is this require function, which is called on the first line of each little snippet. You'll learn all about require in the next section. For now, all you need to know is that it's a way to get functionality from another file. So in this case, both of these scripts, they load in a function defined elsewhere, and they call them a couple of times to perform some I/O operations. The I/O operation for both is attempting to do the same thing. So over here for the blocking example, the goal is to take in a user ID and then go off to a database and actually fetch that user's profile information. And we do the same thing over here in the non-blocking example. So to start, we try to fetch the user with an ID of 1, then we print it to the console. We do the same thing over here using a slightly different pattern, which we'll get into shortly. Then over here, we try to fetch the user with the ID of 2, and we print that to the console, and we do the same thing over here. Finally, both snippets attempt to add up two numbers and print that sum to the console as well, and that's all they do. Now down below, I have some units for each timeline. That's going to help us compare the relative operating speeds. They're not exactly seconds, but for the sake of this example, you can definitely think of them as seconds. And now we're actually going to run through each, seeing how they execute. We're going to start with the blocking example, and for both examples, we're going to ignore that first line. The first line is the same for both, and it's not part of this whole blocking versus non-blocking discussion. So the first thing we really do over here is we pass 1 into getUserSync. The goal here is to go off to the database and get the user profile for the user whose ID is 1. Now, what does that look like? Well, down below, it looks a bit like this. Here I have a block representing the time this entire operation takes to complete, and in this case, I've chosen to make the length of our I/O operation 2 seconds. And that's going to be the exact same length of all I/O operations in these examples, regardless of whether it's blocking or non-blocking. So this includes everything. It includes initiating the request and actually waiting for the database to fetch the data and send it back to our node application. So once that's done, what do? We go ahead and just print user1 to the console. That is not an I/O operation, and it runs really quickly. From there, we continue working through our program one line at a time. We go one after the previous. So right here, what do we have? We have user2, and we get the second user by passing 2 into getUserSync. Once again, we wait 2 seconds to actually get that second user. Right here, these two blocks are the exact same length. The next thing we do is we go ahead and print that second user. That happens on line 7. Once again, not an I/O operation. It runs really quickly. And the same thing is true of the last thing we do, which is we calculate and print the sum. So this is the order of operations, and this is the entire time it takes to run. In this case, let's say it's basically 4.5 seconds. Now you'll notice the bulk of this 4.5 seconds is taken up by fetching second user and fetching first user. And while that's happening, our app isn't doing anything. It's waiting for the database to send the data back. It's not actually doing any work on its own. Now let's go ahead and run through the example on the right to see how this differs even when the I/O operations still take 2 seconds. The first thing that happens over here is the same thing that happened over here. We are attempting to fetch the user with the ID of 1. So what does that look like? Well, you'll notice that over here, we're actually passing a function in as our second argument to get user. This is using the callback pattern, and if it's something you're not familiar with, if this code looks really foreign, that is a-okay for the moment. We're actually going to cover all of this in detail in the class. For now, we're just using it to illustrate at a high level the differences between the two patterns. So over here, what do? We start to fetch the first user. Now, the first thing you're going to notice is that this is not a 2-second operation. It happens basically instantly. That's because we're not waiting for the response from the database. That's the long-running I/O. Instead, we are just starting that process, allowing it to run in the background. So right here, we are essentially registering our I/O event with Node.js, telling it to call this callback when at some point in the future, we get the response we were hoping for. Now, the same thing is true down below. So the next thing we do is we actually start the process of fetching the second user exactly like we did up above. So at this point, Node is actually waiting for 2 long-running I/O operations to complete, and they're both happening in the background. It's not taking up our application's time, preventing it from doing other things. And we can prove that by talking about the next step. The next thing that happens is we actually calculate and print our sum. These 2 lines down below, they do not care about the user response for either user 1 or user 2. They should be able to operate completely independently, and that's what we're seeing right here. There's no need to wait for those 2 responses before calculating and printing the sum. Now what happens? Well, I mentioned that regardless of which example we're working with, the I/O operation doesn't get shorter. It still takes those 2 seconds. So right here, I have a box of the exact same width as our two boxes over here, and it's a dashed box, and it represents the time our Node app has to wait for a response to come back. Now, the nice thing is that while it's waiting, it can still do other things. So while it was waiting for user 1, it was able to start up another request, and it was able to calculate and print the sum. Now, after those 2 seconds, we still get the user data back. This is when Node.js calls our callback function, and we are able to print the user, and that's what I see right here. Next up, we wait for that second request. This starts just a little bit later than the first, and it finishes a little bit later. And once we get that data back, we are able to print the second user to the console. If we look at the total operating time, I can see that the non-blocking example was able to finish in just over 2 seconds, while the blocking example was able to finish in just over 4 seconds, a difference of 50%, making the non-blocking example twice as fast. Now, obviously, that's because we were able to overlap the part of our application that took the longest, which was waiting for the I/O to finish. Down below, we were able to wait for both at the same time, and while we were waiting, our app could even perform other things like firing off another request or calculating and printing the sum. That just is not possible using a blocking model. So in this course, we're going to be working with non-blocking code throughout the class, and that's what makes Node so ideal for things like server-side development, where we're making web servers and application backends. It's going to allow your Node app to process multiple requests at the exact same time for different users. So you could be fetching some data for user 1 while processing a new request from user 2. Now let's go ahead and run some Node code to actually see these two examples in action. Right here, I'm going to put on a quick demonstration actually running the two files we just had over in that visualization. On the left, I have my blocking example, character for character, what I had in the other file, and the same thing is true on the right with the non-blocking example. Once again, you don't have to worry about opening this project up or writing this code. This is just for demonstration purposes. We'll start diving into coding together in the next video. For now, what we're going to do is run these two scripts to see how they execute, which is going to be exactly how we described them in the visualization. On the left-hand side, I'm going to use one terminal for the blocking example. On the right-hand side, I have a second tiny terminal for the non-blocking example. Now, to actually run a file, we still use that node command, followed by a space and the file name. So here, node space blocking.js is the file I'm trying to run. Now, to make things easier to see, I've delayed the I/O operations to take 5 seconds, so it's a bit easier to talk about things as they're happening. Let's go ahead and kick off the blocking example. So what happens? Nothing. We are sitting here and we're waiting, and we are waiting for a full 5 seconds before that first user comes back. There it is. We have their ID and their name. Then we wait another 5 seconds to get the second user. Finally, the sum prints exactly as we saw over in the visualization. So 5 seconds for Jess, 5 more seconds for Mark, then basically instantly after Mark printed, we got 34 printing. So this is the blocking example for a total runtime of just over 10 seconds. Now let's try the non-blocking example. In this case, getting the user still takes a full 5 seconds. So right here, node space, the file non-blocking.js. I'm going to go ahead and run it. And once again, we get the number printing right away. It started up the two I/O operations. It printed the number. Then 5 seconds later, both basically printed at the exact same time. That's because we were able to overlap the process of our Node app waiting. So the total runtime here for our non-blocking example was just over 5 seconds, once again, running twice as fast as the blocking example over here. So that is it for our little illustration of blocking versus non-blocking. We're going to talk a lot more about this a bit later in the class when we start to get into some more advanced Node.js application code. For now, though, we have done a pretty decent job at exploring this second sentence. Node.js uses an event-driven non-blocking I/O model that makes it lightweight and efficient. So we now know what non-blocking I/O is, and we've seen that it definitely creates a more lightweight and efficient application. And event-driven is just that process of registering those callbacks and having them called when the I/O operation is done, and it's something we will talk about in detail later on in the class. The last sentence we have here: Node.js's package ecosystem NPM is the largest ecosystem of open source libraries in the world. Now, NPM is a tool that was actually installed on your machine when Node was installed, and you can find the website at npmjs.com. Here, a website we'll be spending plenty of time in the class. You can search for all sorts of pre-written packages that you can use inside of your application. So if you want to validate emails, there's a package for that. If you want to send emails off or communicate with a database or create a web server or pretty much do anything else you can do with Node, there are libraries and packages that make your life much easier. We're going to make heavy use of NPM packages throughout this class, which is exactly what real developers do when they're building out Node applications. This is something we'll start to explore in the very next section. So we know a little bit about what Node is and why it's a tool worth learning. In the next video, we're going to wrap up this little introductory section by actually creating and running a script on our own. I'm very excited to get to that, so let's go ahead and jump right in to the next video.